Good afternoon. Let me bring you in here. Good afternoon. And it's 3:10 p.m. Eastern Time here in DeLand, Florida, and it's 84 degrees. Perfect. Okay, we're going to talk about the Dragon launch tonight, SpaceX, and it will be at 8:28 p.m. Eastern Time. What's so special about this one is it's going to travel north after launch, meaning, let me turn myself off so I don't have to hear me. Turn the monitoring off. Okay, I don't hear myself now. Um, Meaning that it's traveling north. So when it leaves the Cape, it's going to go up the coastline of the United States. People in Georgia will be able to see it. People in South Carolina, blah, 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 New York State, New York City, Massachusetts, New Hampshire. I have friends up in New Hampshire that when they have a Dragon launch, this is going to the space station. It's a resupply. They're able to see it just as good as me down here. Now, what they're going to see a little bit better than me is that the rocket will be at incline coming from the southeast, and the plume from the exhaust, the fiery plume, you're going to be able to see it. It's gonna be pretty big. Now, when I see it here, I'll see it like that for a brief second, and I'll be able to track it tonight when I record it. My camera gimbal actually will track the Falcon 9. I'll be able to track it all the way up to New Hampshire and hopefully further. So I just wanted to bring, here's the path that it's going to take. And as you can see, it's going to be hugging the coastline of the United States. Awesome. So get out at 8:30, and like I said, look to the south, and you'll see it coming up over the horizon as it zooms past, because it's going to be pretty much booking at that time. And go on YouTube, and you'll find live uh, streams there of the launch. And also, if you go to Twitter or X now, um, that's where SpaceX is doing all their. You'll have to excuse me. First time ever for this program to just crash. Now, as I was saying, get out at 8:30. Go to YouTube. I'll I'll see about posting a few of the sites, independent sites, that will be also tracking the launch. And I'll put them in the description. I'm having a little problem with my audio. There's always something. Yeah, turn myself off again. Let me just check here. Okay, I'm live on YouTube. I just wanted to check the stream if it was going now. All right, we're back to not square one because I already talked about the launch tonight. Get out there. If you've never seen one and you can't make it to Florida, tonight's tonight. Now, what I'm going to show are some images that I've taken over the years, and I just happened to come across all these. Moon, uh, these close-up moon images are taken with the telescope. Some with an 11-inch, like this one, 11-inch Smith Cassegrain from Celestron, and a Sony 7S3 camera. And some of them are taken with this iPhone that I'm using here. And some of them are taken with that same camera, but with camera lenses. So we're going to pop through these. I don't know how many images I have. This is the moon. Another one is the moon. I won't say moon every time, okay? This was taken with a Raza, Celestron Raza, RASA. It's an F2 system. Very fast. The camera, I believe I got an image of the telescope. The camera goes into the front of the telescope facing the primary mirror. And you can't use the telescope for visual observing. There's a eclipse. Actually, this eclipse here, uh, I'll find the video. Actually, right about this time during the eclipse, a large meteor hits the moon on the about 7 o'clock position in the southern hemisphere there, and I just happened to catch it. Good for me. All right, let's see what this next one is. Here's another image here. Here's a close-up of Copernicus coming up here. Oops. There we are. There's Copernicus. Close-up shot of the moon. These are all taken with one shot. There's no stacking. No, I thought I turned all these on. All right. And then this is the moon during the daytime. With the 11-inch Smith Cassegrain. This is, I keep on turning, for some reason, turning off the images. Okay. This was taken with this iPhone here. That's the moon during the daytime. And I believe this next one is, I just happened, let me kill myself here, to capture this one. It's a long exposure. Oh, I don't know how many seconds, but there's an airplane. That's not the space station. I thought it came out pretty good. See if this one is the same setup that night. That streak there is the space station exposure, so you can see it streaking across the sky there. It's fairly bright. Let's see what this next image is here. There is Jupiter and Mars. This is called a conjunction, where two planets or bodies get relatively close to each other. This is only 35 arc minutes, just a little bit more separation than a full moon. And you're going to say, well, the full moon's pretty big up there, so it's pretty. Next time you go out, put your finger over the moon, you'll see how small it is. Put your little pinky there. You could probably cover it with your uh, little pinky there. Okay, this is Ursa Minor. That's the Little Dipper. And at the bottom is Polaris, or North Star. This was taken with. I did stack some of these. I probably stacked it. I forgot to put the number of stacks. Around 250 images. And let me explain stacking to you. Um, Stacking, you stack images, your program will align all the stars because they're going to drift. Your program's going to align the star. What's good about stacking is you can take shorter exposures, like these were. These were like a half a second, and you can take shorter exposure with less noise, and then when you stack them, let's say you stack 300 images, that's like taking a 5-minute exposure. So there is a lot of benefits to this is Vega, and Lyra is the um, constellation that Vega is in. I believe Vega is the second brightest star in the sky. This is the images. Let's see here. 250 images. This is the Ursa Major, or the Big Dipper, or the bear right above the tree there. And Polaris is just barely above that tree right there with the label. This is Ursa Minor at the bottom, and North Star right above that little logo there with the little uh, label there, and then above is the Big Dipper. We're just going to call it the Big Dipper. Why don't we just do that? Now, this next shot is a conjunction of 4 planets. I'm pretty sure that's what this next one is. So we have Jupiter, Venus, and we got the moon, Mars, and Saturn way up at the top there. This is a super conjunction. All 4 of these were rising just before the sun. I believe 120 stacked images. So it was like a half-second exposure or maybe a quarter-second exposure. Like I said, the program will stack all the images, and it will be just like if you took one 3-minute, 5-minute, or 10-minute exposures. Next shot is everybody's going to recognize this is Jupiter. That was taken with the Celestron 11-inch Smith Cassegrain. And where's that elusive red spot? Here's the red spot. Yeah, let's go further out in the solar system. I have to put a Saturn in here. Saturn is just awesome. I'll put a Saturn next time in here. But past Saturn is Uranus. Uranus. Pronounce it that way, please. And here's a shot of it right here. And then here's a shot of it and 4 of its moons. They're all labeled there. These little specks. And oh, this is M13. It's in the constellation Hercules. This was taken, let's see, I got the date on this one. This is called a globular cluster. All these stars packed densely in in like a ball or whatever. Let's see, 35 exposures at 15 seconds each equals 9 minutes. If I just took one 9 minutes, and the focal length on the telescope is 2,800 millimeters, and f10. This I'll just say it. This was shot 16K. That's how big it is. Image, and I took it June 14th, 2016. So that's 7 years ago. God, I'm getting old. I, we're seeing my background here. I don't know why, but let's see what this image behind it is. We'll just bring it up. This is the Orion Nebula, and I don't have any info on it, but it's in Orion's belt. Very easily seen uh, in a telescope. You can see it in a small telescope, but once you get up to larger telescopes, you start seeing color. Believe it or not. What is this shot here? I don't know if you can make it out here, But just to the right is Orion. You got two bright stars that are kind of cocked to the right, and then you got three stars below it, cocked to the left. That's his belt, and then you got a little stream of what looks like three stars there. Orion is right in the middle of that, and the top star is, let's see, now my brain is playing numb right here. It's Beetlejuice. Ah, there we go. I pulled that one out. Okay. Yeah, the movie Beetlejuice. Just don't say it three times. And the bright star left of center there at the bottom is Sirius, and I mentioned that earlier. It's the brightest star in the sky, but it's only visually. That's because it's closer than most stars of that size, and it's technically not the brightest, but just for our visual, it is bright. It is a very bright star, and I have a SpaceX that I'm going to launch. So I'm going to show you that the Falcon actually goes right over Sirius and loops down. You'll, you'll see what I mean in a second here. And let's see, what's this last image here? Okay, this is another shot of that conjunction. We got Jupiter, Venus, Mars, and Saturn. I thought I turned these on here. Let's see here. What is this here? Okay. We're back to that one shot there. So I did make a little mistake here. Let me bring up my background image. And I thought I had that turned on, but I guess I didn't. So that's host of a few images. Like I said earlier, get out to see this launch here. This is going to be spectacular. This is a SpaceX launch here, and if you go down at the bottom, this is called a jellyfish launch, and it's just before sunrise. And what happened is when there was separation between the first and second stage, there's all this gas that's expelled into the upper atmosphere. It's pretty big, and it's being lit by the rising sun. The sun's got about another 45 minutes uh, to rise, but it's high enough to where the sun shines onto these gases. Now, if you look there, you can see a nucleus there at the bottom of that teardrop, and that's the second stage of the Falcon 9. And if we look over real close to the right there, directly right about 4 o'clock, that's the first stage. Let's see what we got here. This is my studio in Denver, which is packed up, and hopefully soon we're going to be able to get out there and get it. I have an 85-inch TV that I use to monitor uh, YouTube with, and then just everything to make the magic happen. Okay, I thought I had a photo of a Raja here. Let's see if this is it here. Nope, that's not it. That's not it. All right, instead of hunting and pecking, and it says Feeney for some reason. We're not done yet. Oh, when it crashed, it didn't save uh, my settings and everything. I think the next time before I go live, I will um, set everything up and close out the program so it saves it. And then if it does crash, I don't have to reset up everything. I'm going to play probably the best video of a launch that I took. I was last Friday. Let's go ahead and bring it in here. Here's the flight path. It's pretty much southeast here. We are all set and ready to go. Yes, we are.
Vehicles in startup. SpaceX launch director, go for launch.
And we are go for launch here. It will take after
T-minus 30 seconds.
yeah,
15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. Engines full power. And liftoff of Starlink. Go Falcon, go Starlink.
let's go.
Vehicles pitching downrange. Motion is nominal.
I'm trying to get the header here, covering up the countdown. There were crashes. The sky's starting to glow a little bit, and when it hits 1 minute, it will be above the roof line.
Vehicle
And like I said,
supersonic. Power and telemetry nominal.
this camera, or this camera gimbal, camera will track this rocket.
Max Q. Impact chill.
Let me at least kill the header here. There we go. My bad. I've only done a few of these, so I'm learning. Excuse me if you hear my slurping. Drinking my second cup of coffee of the day. And here we are. We're going to zoom in a little bit. Now turn that 90 degrees, and that's what you're going to be seeing tonight.
Miku. Stage separation confirmed. Invac ignition. Fairing separation confirmed.
It's about 1,000 miles downrange. We're up on Puerto Rico right now, I believe. We're in the Dominican Republic and Haiti. And once I decide to cut off the video, the SpaceX will go live full screen. There we go.
Vehicles on nominal trajectory.
Wait, it's almost 4 o'clock here. We're about another 3 minutes
Stage
of this
1
video.
FTS has safed.
Stage 1 entry burn startup. Stage 1 entry burn shutdown.
Stage 2 FTS has safed.
And it's about 25 kilometers from the landing zone.
Stage 1 transonic.
Meaning that it's traveling just under the speed of sound. So it's decreasing.
Stage 1 landing burn.
Oh, we're getting close. There it is.
Stage 1 landing leg deploy. Stage 1 landing confirmed.
I thought I'd insert that in there because I guess we no longer have. The cheering and everything.
There you go.
From the engineers. Adios. Little thumbs up. And this is the equipment I used and blah, blah, blah. Let's see if it comes back. Oh, here we go. My bad. I accidentally closed the program out. Oh, yeah. Well, we're going to end the live stream right here. And hopefully you'll have a blessed rest of the day, and tomorrow sunny and will be fruitful. Hopefully your day was fruitful today. And we'll see you then.